So the last piece of the puzzle of dealing with propositional logic is to learn the various standard forms of propositional syllogisms and the fallacies that are connected to them. As we'll see, many, though not all, of the arguments in propositional logic have standard distinct forms that can be immediately recognized as either valid or invalid based simply on our understanding of the form alone. So what we'll be doing in this video is looking at and ultimately attempting to memorize several standard syllogisms in propositional logic, as well as their related fallacies. And as we'll see, this is really central for understanding the next module, and so this will function as a nice segue into the discussion of natural deduction. So there'll be a number of standard syllogisms forms, and what we can do is simply list these as we go. The first of these is called a disjunctive syllogism. A disjunctive syllogism is a rather classic form of propositional reasoning, one that is, I think, very intuitive and one that you will recognize fairly easily. Now, the Latin name for this is modus tollendo ponens, and in this particular instance, I don't really care if you know this name. In later syllogisms, we'll see that the Latin name is, in fact, just the name you'll need to know. So there'll be a few cases as we move along where you're going to need to know this. But the kind of classic Latin phrase for this is modus tollendo ponens. Now, to define a disjunctive syllogism is a valid form of argument in which one premise, our main premise or major premise, is a disjunctive statement. The other premise will be a denial of one of the two disjuncts that are given in the original disjunctive statement, and then ultimately the conclusion should be an affirmation of whatever is left over. So if we want to basically start defining our terms, remember that a disjunctive statement, and that's going to be the main premise of this kind of argument, a disjunctive statement is quite simply an either-or claim. Right? So in this particular instance, we have it as either P or it is Q. And of course, this will be the foundational building block of this kind of argument. The main premise of this argument is simply a disjunctive statement. Now, I could technically have more than just these two, but standard forms will usually have just two. And of course, the disjuncts are the two pieces of the disjunction, the things that sit on either side of the wedge. So whatever P stands for and whatever Q stands for, these would be just my disjuncts. And notice the second premise will traditionally want to deny one of these two terms. So basically, the first premise is going to say it's either P or Q, and the second is going to say it is not P or it is not Q. Now, to remind you very quickly of some translational issues, ones that I promise you you'll have to deal with on the test. The standard form for a disjunctive proposition is simply either A or B kind of thing. And of course, notice the wedge there represents the either or, and I'll have an A or a B or whatever my terms are on each side. But a very common non-standard way of expressing a disjunctive proposition is by the use of the term unless. So when I say things like A is true unless B is true, or unless A is true, B is true, or something along these lines, notice that the proper translation of this will usually be just it's either A or it is B and nothing more. Now, to take a slight detour here, I think a really easy and very intuitive way of thinking about how a disjunctive syllogism works is to go to the rather classic and fairly boring game Clue. Now, if you haven't played Clue, then you can kind of just ignore this, but if you have and you think about what Clue is doing, this is really just a series of disjunctive syllogisms running through the game at the same time. So think about how this game is played. What you have essentially are, I think, 7 or 8 different murder suspects. And what we do is you have cards that represent them, you shuffle them, you pull one card out and stick it in an envelope. And the rest of the game, what you want to do is look at all of the other cards that are not in the envelope so that you can figure out which one has to be in there. And of course, if there are 8 cards in total and one of the cards is in the envelope, if you look at all 7 of the other cards, whatever you haven't seen has to be the card in the envelope. And that's basically how a disjunctive syllogism works. It's kind of a process of elimination in its standard form. So let's take a look at an example of a disjunctive syllogism, and we'll use the game clue to get there. Now imagine you've narrowed it down to two suspects, and so the argument runs, the person who committed the murder must either be Colonel Mustard or Miss Scarlet. But we now know that Miss Scarlet was in the library at the time of the murder, so what we're saying there is she couldn't have done it, and thus the murderer must be Colonel Mustard. Stated formally, notice that the first premise here is simply our disjunctive statement. Either Colonel Mustard committed the murder or Miss Scarlet committed the murder. And then pay close attention to what happens in the second premise. The second premise comes along and denies one of these two terms. So in this case, it says, it is not the case that Miss Scarlet committed the murder. And then our conclusion simply draws an affirmative claim about whatever is left over. And if you think about this reasoning, it's fairly compelling stuff. If it is in fact true that one of these two individuals did in fact commit the murder, it was Colonel Mustard and Miss Scarlet that committed the murder, and we now know that Miss Scarlet did not commit the murder, then it follows necessarily that Colonel Mustard did. So notice the basic structure of this. Again, the first premise is simply a disjunctive statement with two or potentially more disjuncts as its basic terms. The second premise will attempt to resolve this argument by appealing to our various disjuncts. And typically what we're going to see is that we're going to try to deny one of them in order to affirm whatever's left over. But keep in mind, it's possible that you can, in the second premise, affirm. This might make it an invalid argument, but there are weird conditions that can make it valid. We'll talk about that soon enough. But the basic point here is the second premise is going to try to resolve the argument by appealing to one of our disjuncts and typically by denying the truth of it. Now the conclusion then will infer a statement about whatever disjunct is left available to us. In this case, of course, it's Colonel Mustard committed the murder. And notice that what has happened in the conclusion versus the second premise is that I've moved from denying one to affirming the other. So in the conclusion, you will typically want to do the opposite of what you did in the second premise with whatever remains. Now we could run this through a truth table to show that it's valid, and you're free to do so if you want to get some practice in. But if you look at this, the basic form we're looking at when we get a valid disjunctive syllogism is that you want to deny a term in the second premise and affirm whatever's left over. Now, the little smiley faces here are kind of a silly way of remembering this, but think about in the second, you're denying, and so you're frowning, and then of course you're happy at the end, and when you're happy at the end, it's because it's a valid argument. Now keep in mind that the standard form of a disjunctive syllogism, a form that will always be valid, is if I have my disjunct and then what the second premise does is deny terms in the disjunct and the conclusion will affirm whatever's left over. So basically from premise 2 to the conclusion, you want to deny in order to affirm. So let's look at another example that has nothing to do with the game clue. This argument says, my car won't start, and it seems that either the battery is dead or something is wrong with the starter. But since the lights still work, the battery can't be dead, and thus there must be something wrong with the starter. Notice that this kind of reasoning, disjunctive syllogisms or disjunctive reasoning, is in fact something that is really common when we are troubleshooting things. And this is a good example of that point. So in this argument stated formally, the first premise simply lists our alternatives. It says one of the two things that must explain what is wrong with my car is either that the battery is dead or the starter is broken. The second premise says the battery can't be dead. And of course, that would follow if the lights still work in your car because you have power. And notice, if it's not the battery, and the only two options in terms of explaining what is wrong with your car is that it is a dead battery or a broken starter, then of course the conclusion is going to be that the starter must be broken. So again, notice the form here. The first statement, the main or major premise of this entire argument is simply a disjunctive statement. In this case, we have two terms, and then what we do from there is simply try to resolve those terms through the next two statements, the premise and the conclusion. The second premise will resolve this by denying, ideally. You can potentially affirm, but you want to deny terms. and whatever's left over would have to be affirmed. Now notice what we're looking for, ideally in this kind of an argument, is this move in the second premise to deny in order to affirm in the conclusion whatever's left over. So deny to affirm is the standard valid form of a disjunctive syllogism. And if you have this form, it will always be a valid form. Now, of course, it doesn't mean it's true. In this particular instance, the fact that your battery is dead or the starter is broken might not be the only two possible explanations of what's wrong with your car. Maybe your ignition's dead, or there could be countless other things. But the simple fact is, if it were true that those are the only two possible explanations, if I can eliminate one of them, whatever is left over in the original disjunction has to be the case. Now let's look at it in terms of an invalid argument. So this argument says my car won't start, and it seems that either the battery was dead or something was wrong with the starter. I took the battery in to have it tested, and it was dead, so luckily I don't need to buy a new starter. Now, in terms of the basic form, the starting point here, of course, is our main premise is just a disjunctive statement. And then notice what happens in this case. In the second premise, I affirm the truth of one of my disjuncts. In this case, I say the battery was dead in order to draw a conclusion at the end about the other term. And in this case, what I do is deny it. So let's walk through the parts of this. Notice the major premise or first premise of this argument is simply our disjunctive statement. The second premise does exactly what we've been talking about, but in this case, it does it in the opposite way. What we do is attempt to resolve this argument by appealing to the individual disjuncts of the original disjunctive statement. And in this case, what it did is affirm one of the disjuncts as true, and then it draws a conclusion about whatever disjunct is left over to us. And in this case, it's S, and we're denying it. I'm saying so it can't be S. Now, notice this is an invalid argument, and it's invalid if you think about it for a pretty obvious reason. There's nothing necessary about this conclusion. The fact that the battery was dead is not sufficient reason to think that the starter isn't broken too. I haven't eliminated that possibility. And frankly, if you've ever owned a car, it's very likely that one or more of these things is going to be broken. Notice in this case, what makes this invalid is that the disjunction itself is simply an inclusive disjunction. There's nothing about this that says it can't be both. So simply saying one must be true is not enough to say that the other one is not true. So notice when we're looking for, in terms of just the basic form, what makes a disjunctive syllogism invalid, what we're going to do is affirm to deny. So notice at the end, if you just go with our stupid smiley faces here, the second smiley face is super optimistic in the second premise, and then you're unhappy at the end because you've made a bad inference. And what we get here is called the fallacy of affirming a disjunct, and you need to know this. Now, we'll see in a second here, there's a catch here, but this is a fallacy that is distinctly associated with a disjunctive syllogism. Now, to try to make sense of this caveat or this catch I just mentioned with the fallacy of affirming a disjunct, let's take a look at this particular example. This argument says either Bob is in Spokane or Bob is in Paris. Bob is in Spokane, therefore Bob is not in Paris. Notice the basic form of this argument. In the first premise, we have simply our disjunctive statement, Bob is in Spokane or Bob is in Paris. The second premise affirms one of these two terms. It says it is true, or it is the case that Bob is in Spokane, and the conclusion that's drawn from this is it can't be that Bob is in Paris. Now notice this has the form that we are just looking at. What we've done here is affirm in the second premise to deny, and we just said that that was logically fallacious, that this commits a fallacy of affirming a disjunct. But of course, if you think about this argument, it's pretty dang compelling. If it's true that Bob is in Spokane, then Bob simply can't be in Paris. That follows, and it follows necessarily. And so our question here is, what exactly is different about this one and the example we saw with batteries and starters? After all, in both cases, we happen to see the same basic structure. We affirm in the second premise to deny in the conclusion, and that we already said was invalid. So what distinguishes these two arguments? And of course, the difference has to do with our major premise, or the disjunctive proposition in the argument. What we have here is an argument that is saying it is either Spokane or Paris, but it's also asserting that it can't be both at the same time. A person simply can't be in Spokane and in Paris at the same time in any meaningful sense. Whereas with the battery and starter, we're not assuming that it couldn't be both. And so we find ourselves back to this distinction between inclusive and exclusive disjunctive propositions. And remember, an inclusive proposition essentially is saying it is and or, like the battery and starter situation, which essentially says it's either the battery or the starter, but it's quite plausible to think that it might be both of them. Whereas an exclusive proposition is the kind of proposition that says it is either one or the other, but they can't both be true and they couldn't both be false. So notice if Bob is in Spokane, then he can't be in Paris. And if he is in Paris, then he can't be in Spokane. And what we get there is simply an exclusive proposition. And so what this shows us is that when we're dealing with an exclusive proposition in a disjunctive syllogism, then we do not run into a logical fallacy. And keep in mind that when we talk about a disjunctive syllogism, the technical translation of this is P or Q, and it is not the case that it is P and Q at the same time. The presumption in an inclusive is that it is an and or, and it could be both. And remember that there is a sort of shorthand way that you can use so that you don't have to put this more complicated formula into your truth tables. And that shorthand way of dealing with this is to simply change, when you know it's an exclusive, change the top term in your truth table to false. If they're both true, it's false. If they're both false, it's false. And again, I think a useful tool here is to put a little tiny X above the wedge so that you know you're dealing with that problem. So let me take a moment to simply summarize everything that we now know about the standard form of a disjunctive syllogism and the associated fallacies that come with it. The first point is quite simple. In standard form, what you'll have are two premises and one conclusion. It is a syllogism after all, and that's true of any syllogism. The main premise of the argument is simply a disjunctive statement. The second premise is going to work by either affirming or denying one of the disjuncts, and then the conclusion will do essentially the opposite to the other disjunct that's left over. And this is what we're going to look for with a disjunctive syllogism. Now, a valid form, a universally valid form, is when the second premise denies a disjunct in order to affirm in the conclusion whatever's left over. So the basic pattern you're looking for when you have your disjunctive proposition, go look at the second premise and see what you're doing. Are you affirming or denying your terms? If you are denying to affirm, then this is valid. And it doesn't matter if it's an inclusive or exclusive disjunction, it's simply valid and universally so. On the other hand, if you affirm to deny, so in your second premise, you affirm one of your disjuncts in order to deny whatever's left over, we are now in a position to ask some questions about the distinction between inclusive and exclusive. If it is an exclusive disjunctive proposition, that means it's either or, but it could not possibly be both of these two things at the same time, then this is still a valid argument and you haven't committed any fallacies. If, on the other hand, it turns out that it is an inclusive disjunction, then this is in fact an invalid argument. And this is when we get a fallacy of affirming a disjunct. So this is the only time that you actually bump into this particular fallacy. So a fallacy of affirming a disjunct is when you affirm in the second premise to deny in the conclusion, and it is an inclusive disjunctive proposition. And that pretty much sums up the whole of what we need to know about disjunctive propositions. So let me take a moment here to talk about the idea of affirming and denying. And this, frankly, is extremely important. This is perhaps the most difficult part of all of this, of memorizing and understanding these forms, to actually come to recognize. And the important thing here is that when we talk about affirming and denying, don't just go look for a tilde or not a tilde to establish those terms. When we talk about affirming or denying our various terms in an argument, it's really, really important to understand that what we mean by this is always going to be relative to the original term. The easiest way of thinking about this is just ask yourself, do I agree with that original term or not? If you agree, then you're affirming. You're saying, yep, that's true. If you disagree in the second premise or the conclusion, then you're saying, no, I disagree. It is not the case. That is, you're denying. So let me show you what this looks like. So if we look at this particular example, notice the main premise here, the major premise is it is either not P or it is not Q. And then what we get in the second premise is P is true, and the conclusion says, therefore, not Q. Now, it's extremely tempting at this point to assume that because the second premise is an affirmative claim, that I must be affirming one of my disjuncts, and to assume in the conclusion, because there's that tilde there, because Q is being negated, that somehow that must mean that I'm denying my terms. But that's not the point, and this is really important. When we talk about affirming or denying, this will always be relative to the original term. So the way to approach this is to go back to the original disjunct in this case, which is not P and not Q, and just ask yourself, am I agreeing with that statement or am I disagreeing with that statement? Now, if you really stop and think about this, if the original disjunct is not P, if I want to agree with that and say that that's true, that is, I want to affirm it, then what I would have to do is say, yes, you are correct, not P is true. If, on the other hand, what I want to do is deny it, what I would end up doing is saying, no, you're wrong, P must be true. So again, when we talk about affirming and denying, what we're talking about is being relative to the original disjunct in this case, or whatever term it is. If the term is not P, to affirm it, I would have to agree and say not P. To deny it, I'm going to say P is true. And of course, notice what that means in this case. Premise 2 is actually denying this disjunct. I'm saying I disagree with you. If the original claim is not P, to say P is true is to reject that original claim. And if we go to the other side here, notice the disjunct on this side of our disjunctive proposition is it is not the case that Q is true. And of course, if I want to agree with that or affirm this disjunct, what I would have to do is say not Q. If I want to disregard this or deny this, what I would have to do is say Q. And of course, this implies that our conclusion is in fact affirming this particular disjunct. If the original claim is not Q, if I want to affirm it and agree with it, then I would simply say not Q. So this is a very important basic point about all of this, about understanding what it means to affirm and deny. If you didn't quite follow this, I would strongly suggest you rewind the video a bit and watch it again until this starts to make some sense. Because if you don't understand this, things will get very confusing very quickly as we start wading through the quarter. So let's move on. We've already covered disjunctive syllogisms and seen how those work. So now we're moving on to what are called hypothetical syllogisms. Now, a hypothetical syllogism will be a two-premise deductive argument. In fact, this is true of any syllogism, so I have two premises, one conclusion, in which at least one of the premises is a conditional statement, and where the antecedent or consequent of which also appears in the second premise. And of course, what we mean by a conditional statement is just an if-then claim. So something like if P is true, then Q is true. And this will be the fundamental building block of a hypothetical syllogism. Everything simply revolves around conditional statements. Now, to remind you of some of the translational nightmares that are accompanying conditional statements, recall first and foremost that in the standard form, a conditional statement will always have if antecedent and then consequent. What comes first must be the antecedent of the proposition, and what comes after must be the consequent. Now, in terms of translating, the basic rule you need to memorize and get very comfortable with is that if you have an if claim, if I just say if X or whatever, what immediately follows the if by itself there should be the antecedent, and you need to make sure that it sits in front of the horseshoe. On the other hand, when you see only if, whatever immediately follows an only if claim should be your consequent. Now, this translational stuff is incredibly important. It's one of the more confusing parts about all of this. So memorize it, make sure you understand it. This basic set of rules is something that you need to be able to apply. So now we can start to add to our list of standard syllogism forms. We get the hypothetical syllogism, and as we'll see, there are a variety of subcategories that we need to understand that deal with hypothetical syllogisms. The first of these is called a pure hypothetical syllogism. Now, a pure hypothetical syllogism is going to be, first and foremost, a syllogism, which means it'll have typically two premises, one conclusion, and it is built around conditional statements because it's a hypothetical syllogism. So what makes it a pure hypothetical syllogism? In a pure hypothetical syllogism, both of the premises as well as the conclusion are conditional statements. And for it to be valid, what we want to see is that the antecedent of the major premise must match the consequent of the minor premise. That is the driving force in what determines the validity of the argument. So let's look at a really simple example, and we can talk about it in terms of its form and in terms of validity if we wade through this. So it says, if it rains on Sunday, then the concert will be canceled. If the concert is canceled, then we will go to the movies. Thus, if it rains on Sunday, we will go to the movies. Now, stated formally, we have two premises and one conclusion. If R, then C. If C, then M. Therefore, if R, then M. Now, in terms of setting these up in standard form, the first basic rule you need to know, and it's an important one, is this. Whatever the antecedent is in the conclusion should go on the top line. This is basically the opposite of what we saw with categorical propositions or syllogisms. So in this case, go figure out what the antecedent is. In this instance, it's R. And that term needs to show up on the first line of your argument. So stick that on the top. And then once it's up there, what you want to see is that the consequent of the major premise becomes the antecedent of the minor premise, or the second premise. This basic formula is the only valid form of a pure hypothetical. Now, other than this, all of your terms must match. So when it says R, R should match again. If it says M, M should match again. If it said not R, then the term that shares the R term in it would have to be not R. So basically, these are your 2 points. First, set it up in standard form with whatever the antecedent is in the conclusion on the main line or the first line of your argument. And then what you're looking for is simply this basic pattern. The consequent of the first premise should be the antecedent of the second premise. And really, if you think about what we're looking at, the basic structure of this kind of argument, the sort of reasoning we're looking to, is really simple. The first premise says, if A is true, then B is true. The second one says, if B is true, then C is true. And what the conclusion then does is just skip that B term because it's connecting and allows us to jump from if A to C. Here's another example. It says, if Barlach is a spy, then he will deny being one, because if he is a spy, then he is trained to not tell the truth about being a spy, and anyone trained to not tell the truth about being a spy will deny being one. Now notice our conclusion here is if Barlach is a spy, then he will deny being a spy. So we want if S, then D. Now the second premise here says if Barlach is a spy, then he is trained to not tell the truth about being a spy. And of course, notice this has to go on the first line because the first term, Barlach is a spy, which we've identified with the letter S, is contained in this particular premise, and so it goes on the first line. So this is how you'd want to set it up in standard form. Figure out what your conclusion is. The antecedent of the conclusion should be in the first line of the argument as premise 1. Whether it shows up as the antecedent or consequent is irrelevant. That term needs to repeat itself in the first line. And then, of course, The conclusion is anyone trained to not tell the truth about being a spy will deny being one. So we get not T. If not T, then D. And of course, what we're looking for is these terms to simply repeat themselves, where in the first line, the first premise, the consequent, which is not T, it's that total term, not T, has repeated itself perfectly as the antecedent of the second one. And of course, that's the basic structure we're looking at for a valid, pure hypothetical syllogism. And notice the basic pattern you're looking for. If you think about this little triangle down here, that's a really easy way of thinking about it. It's simply saying if A, then B, if B, then C, if A, then C kind of thing. We're using that middle term, the one that repeats itself and that is circled here, in this case not T, as a sort of segue into connecting the first antecedent and consequent in the conclusion. Now let's see what it would look like when it's invalid. This one says if Barlach is a spy, then he will deny being one, because if he is trained to not tell the truth about being a spy, then he must be a spy, and anyone trained to not tell the truth about being a spy will deny being one. So again, we have the same conclusion if S then D. The second premise, notice, the S term does indeed show up on the first line because this first term, the antecedent in the conclusion, needs to go on the first line. Stick it on the top line, we get not if not T, then S. And then our conclusion basically is if not T, then D. And of course, what we don't get is the pattern we're looking for. Since the S term is the consequent of the first line and the not T is the antecedent, it has not repeated itself in terms of this basic formula. And this is what makes it an invalid argument. And in fact, anything other than this one standard form is going to be an invalid form. So let's move on to mixed hypothetical syllogisms. Mixed hypothetical syllogisms are insanely important, really commonplace, and something you need to get very comfortable with. So a mixed hypothetical syllogism is one where the major premise of the argument is a conditional statement, and where the second premise works to register agreement or disagreement with the antecedent or the consequent of that conditional statement. So in this sense, what we have is simply a single conditional statement as the main premise of the argument. And then the second premise is just going to take one of the two parts, the antecedent or the consequent, and say, yep, that's true, or no, that's false, in order to do the same thing in the conclusion with whatever's left over. Now, with mixed hypothetical syllogisms, we have two fundamental forms that you need to know, and their names are in Latin, and you need to know these names. I promise you it's very important. You have a modus ponens and a modus tollens. So we can start with the modus ponens. This is one form of a hypothetical syllogism. It's a mixed hypothetical, and it works essentially by affirming things. So in the second premise, what I want to do is affirm some of the terms in the original statement, the conditional statement, and then in the conclusion, I'm going to affirm again. So a modus ponens, let's start here. A modus ponens is a syllogism where the main premise is a conditional statement, and the second premise asserts as true the antecedent of the conditional premise. And then the conclusion will assert that the consequent is also true. So let's see what this looks like. If we take Barlach again, it says, if Barlach is a spy, then he will deny being one. He is a spy, therefore he will deny being a spy. Now notice the basic structure of this argument says, if S is true, then D is true. The second premise simply takes up that first term, the antecedent in the main premise there, and it says, yes, that is indeed true, and the conclusion will then affirm whatever is left over. Now, if you stop and think about this, why this is a valid form and why this actually works is that when we have a conditional statement, we're essentially giving ourselves a universal affirmative. So if we go back to categorical reasoning, to say if S is true, then D is true, is essentially saying every single S in existence must also be a D, but logically it wouldn't imply that every D has to be an S. And of course, notice if the second premise says for that smaller circle that it's true, so I know whatever I'm talking about fits in that smaller circle, then of course, whatever I'm talking about fits in the larger circle too. If every single S fits into the D circle, and whatever I'm talking about fits into the S circle, then necessarily it must fit in the D circle too. So basically, the move you're looking for what it's worth, is if you look at your first premise, the S, if S then D in this case, the antecedent represents that smaller term, the one that's contained in the larger circle, and the consequent represents the larger term. And notice what I want to do is make sure that the second premise simply says whatever I'm talking about fits in that smaller circle. If every single S in existence must be a D, and this thing is in fact an S, then it would have to be a D. And that is the basic form of a modus ponens. It might be easier to see this point if we just turn to something that is just really, really blatant in terms of the reasoning here. Take the example, if something is a dog, then it's a mammal, which is just saying all dogs are mammals. And again, notice what that means is every conceivable thing that's a dog must fit into the category of mammal, but not every mammal must be a dog. So the argument says if something's a dog, then it's a mammal. Fido is a dog, and therefore Fido is a mammal. And of course, notice if every dog is in fact a mammal and Fido is a dog, it is absolutely necessary that Fido must in fact be a mammal. So basically what we want to see is in the second premise, we affirm the antecedent of the original if-then statement in order to affirm in the conclusion the consequent of this conditional statement. And this is a valid form for a modus ponens. We want to affirm moving in this direction from the second premise to the conclusion. Affirm the antecedent in order to affirm the consequent. This is a valid modus ponens. So we've seen the valid form of a modus ponens. Let's see how it fails or when it is invalid. In this argument, it says if Barlach is a spy, then he will deny being one, which is the same conditional statement we saw in the argument before. Notice the second premise, though, says Barlach keeps denying that he's a spy, and therefore he must be one. So notice the structure of this argument then. The main premise of this argument is simply our conditional statement, if S then D. The second premise takes up the consequent and affirms it as positive. It says D is true. And then in the conclusion, it affirms the antecedent is true. And of course, you can see visually, if you just go back to our Venn circles, why this is problematic. If the original claim is saying every conceivable S in existence must be a D, the mere fact that whatever I'm talking about must be a D, that is, it fits inside this larger circle, is not really sufficient to tell me that it must indeed fit in the S circle. It might, of course, but we don't know. And again, it might be useful to just return to something that's really, really obvious in terms of making this basic point. Think about this example. It says if something is a dog, then it's a mammal. Now, no, we know that's true, and what that's telling us is every conceivable dog in existence is in fact a mammal. Well, notice if the second premise says Secretariat is a mammal, therefore Secretariat is a dog, that becomes rather problematic. And of course, Secretariat was a famous horse. And horses are indeed mammals, so the second premise is true, but there's nothing about the fact that Secretariat being a mammal and nothing about the fact that every dog is a mammal that would guarantee that Secretariat is in fact a dog. So when we have an invalid form of a modus ponens, notice what we're going to do is that the second premise is going to begin by affirming the larger category or the consequent. So we start there with saying D in this case is true, and then the argument moves to the conclusion backwards essentially by asserting that the smaller category of the antecedent is somehow rendered true by this. And this is an invalid form of a modus ponens. Now, what we get here is called a fallacy of affirming a consequent. And if you stop and think about why we give this name to this particular fallacy, what it does in the second premise is simply affirm the consequent, and that's an invalid form. A valid form will affirm the antecedent, not the consequent. So, in fact, when we talk about the fallacies in this particular section, if you want to remember the name for any of the fallacies, this includes a fallacy of affirming a disjunct. Just look at the second premise and describe what you've done. In this case, I affirmed a consequent. With the fallacy of affirming a disjunct, I affirmed a disjunct in an inclusive disjunctive statement. Now, notice we can start to lay this out into a grid. And so far, we've only seen what a modus ponens does, and we've determined that there is a valid form and an invalid form, and we can lay this out into a nice little table. Our valid form essentially wants to affirm the antecedent in order to affirm the consequent. Remember, modus ponens works by affirming things. The invalid form reasons backwards by affirming, and we get what is called a fallacy of affirming the consequent. So I promise you that these will be insanely important things. Not only will you bump into modus ponens and modus tollens over and over and over again, but if you don't understand these, the final type of syllogism we're going to look at, which is a dilemma, is not going to make any sense at all. So these are very important. It is worthwhile to memorize these basic forms and get comfortable with what they mean. Now, the last type of a hypothetical syllogism, which is also a mixed hypothetical, is a modus tollens. And it's very much like the modus ponens, but you might say it does everything backwards. Modus ponens works by affirming, and ideally it starts by affirming the antecedent in order to affirm the consequent. Modus ponens works by denying, and it does all of this backwards. So a modus tollens, let's see what this does for us. A modus tollens is a syllogism, a mixed hypothetical syllogism, where the main premise is, of course, a conditional statement. So I have a single conditional statement, and then the second premise works by denying the truth of the consequent of the conditional premise. And then, of course, the conclusion is going to work by denying, once again, the truth of the antecedent. So I want to deny in both cases or affirm in both cases, which is just the opposite of a disjunctive syllogism. So let's take an example. If there's a snowstorm, then school will be canceled. School has not been canceled, and therefore there has not been a snowstorm. Now notice the basic structure of this argument. It says, if S is true, then C is true. The second premise says it is not the case that C is true, so it denies the truth of the consequent in order to, in the conclusion, deny the antecedent. So I'm reasoning backwards in this case. And again, we can use our Venn circles to actually see intuitively why this type of argument works and makes sense. Why is this a valid argument? Well, notice if it's true that every single instance of S without fail will necessarily produce C, that is, every S fits into the C category. And if I know that the C category does not apply, we're not inside that large circle anywhere, then of course there's no possibility that I would ever have anything in the S circle, since every S fits into the bigger category of C. So notice, if it's true that every S fits into the C circle, and whatever I'm talking about doesn't fit anywhere into that bigger circle, then it can't fit in the small circle either, because the small one's always inside of the big one. And again, it might be useful to just stick this particular form of argumentation into a more blatant example with dogs and mammals again. Remember, if the claim is all dogs are mammals, or if something is a dog, then it's a mammal. Notice if I say Nemo the clownfish is not a mammal, therefore Nemo is not a dog. This makes perfect sense, doesn't it? Because of course, if what I'm talking about isn't even a mammal, then there's no chance it could be a dog as well, because every single dog without fail has to be a mammal. And so if I can eliminate that larger category, it takes everything inside with it that could possibly fit into that category, and that would include the smaller category that we're talking about, in this case D. So notice our basic structure here. What we're looking for with a modus tollens is that in the second premise, we go to the consequent of the argument and deny it. And then moving in the backwards direction here, that allows me to take with it the smaller category, or to deny in the conclusion the antecedent. So for a modus tollens, it's pretty much exactly the opposite of a modus ponens. A modus ponens affirms in kind of the forward direction. A modus tollens denies moving backwards from the consequent to the antecedent. And this is a valid form of reasoning. Now, let's see what happens when you flip it around. In this case, it says if there is a snowstorm, then school will be canceled. There is no snowstorm, therefore school will not be canceled. Now, the basic structure of this, of course, says if S, then C. It is not S, therefore it is not C. And of course, what we're talking about here is exactly the same sort of thing. And if we go to our Venn circles, we can see how this would work. The original claim says every single S must be a C without exception. But of course, in the second premise, is if all I am able to do is eliminate the possibility of whatever it is we're talking about fitting into this smaller circle, the S circle, that doesn't guarantee me that what I'm talking about doesn't fit into the larger circle. There's nothing about the fact that it can't be an S that wouldn't say it's still possibly a C, because C is a larger category and it contains more things than simply S. One last time, let's just throw this back into the dogs and mammals kind of example. Notice if I say if something's a dog, then it's a mammal, that's an undeniably true claim. But if in the second premise, all I can tell you is whatever I'm talking about is not a dog. So if I say Secretariat, the horse is not a dog, therefore Secretariat is not a mammal, this clearly doesn't follow. And for the reason that just because it's not a dog wouldn't imply it's not a mammal. Mammal is a much larger category, and it includes things like human beings, cats, horses, and so on. And so just proving it's not a dog is insufficient to show us logically and necessarily that it couldn't also be a mammal as well. Even if it turns out that it's not a mammal, it doesn't logically follow from this evidence. So notice what we're looking for in this particular example. The invalid form of a modus tollens is going to start with the second premise denying the antecedent, and then move forward from that to deny in the conclusion the consequent. This is the invalid form of a modus tollens. And again, the basic reasoning here is really simple. If all I can do is say that the smaller category, which fits inside the larger category, is that the smaller category doesn't apply, that's not sufficient to tell me that the larger can't be true. And so what we get here is called the fallacy of denying the antecedent. And again, just think about what you've done there. Go look at your second premise and describe what you've done. I've taken the antecedent and I denied it. I get a fallacy of denying the antecedent. Now, notice in our grid here, I have a valid form of a modus ponens and a valid form of a modus tollens. And just look at this for a little while and you can see that they're working exactly the opposite of one another. Right? A modus ponens wants to affirm by starting the second premise, affirming the antecedent. The modus tollens denies the consequent and then reasons backward from there. And of course, the invalid form of each is going to be pretty much the opposite in the same way. In this case, we get a fallacy of denying the antecedent when I start by denying the antecedent of the original conditional statement in order to deny the conclusion. Now, this basic picture you see right here in front of you is insanely important. I would strongly encourage you to memorize this, to get very, very comfortable with these forms. They will be useful over and over again all the way through the rest of this particular class. Now, at this point, we're left with only one standard form syllogism to consider, although, like we saw with hypothetical syllogisms, there will be a variety of forms, in fact, two other forms. And what we get now is called a dilemma. A dilemma is actually a rather interesting type of propositional argument, and it's one that has a kind of unique, intuitive feel to it. It can also be a bit confusing because you can kind of start to mix and match things. And what it will ultimately end up doing is borrowing some of the information we got with the disjunctive syllogism and borrowing the ideas of both a modus ponens and modus tollens, and then sort of mix and match these two things. Now, formally defined, first of all, a dilemma is a syllogism. So technically, you will have two premises and one conclusion. The main premise of the argument is simply a disjunctive statement. So what we start with is simply an either or claim. And then the second premise of the argument will be comprised of two conjoined conditional statements. So what we have are conditional statements that have been put together by an and claim. And then essentially we will resolve the disjuncts by way of each of these individual conditional statements. So let me show you by way of an example what this would look like. To begin, the first and main premise of the argument is technically always going to be just a disjunctive statement, something like it is either P or it is R. The second premise is a set of conjoined conditional statements. So notice I have on one side of this conjunction, because it is a conjunction, just an and claim. On one side, one of my conjuncts is simply a conditional statement, if P then Q. And on the other side of the conjunct, I get another conditional statement which just says, if R then S. And then the conclusion is simply going to attempt to resolve the basic disjunctive terms in the original statement by filtering it through each of these conditional statements. So in this case, we get something like Q or S, and we'll see how this works. In the end, basically what we're doing is following the rules of modus ponens or modus tollens with each of these conditional statements. Now, a dilemma breaks down into two different types. We have a constructive dilemma or a destructive dilemma. And the difference here really just appeals to the use of either the rules of modus ponens or modus tollens. A constructive dilemma works by affirming things using the rules of modus ponens. A destructive dilemma works by denying things, and it's just using the rules of modus tollens. So if you keep this in mind, what this means about a dilemma is that to understand our two different types of dilemmas, you need to be very, very, very clear on understanding the rules of modus ponens and modus tollens. If you don't know those rules, when those are valid or those are invalid, you're not really going to find yourself in a position to determine the validity or even the type of dilemma that you're talking about. So let's start with a constructive dilemma and see what this would look like. So we can place this onto our chart. We're down to basically two possible standard form syllogisms left. We have a constructive and destructive dilemma. So the constructive dilemma here, again, follows the rules of modus ponens. So here's a simple example. It says, in premise 1, it's either P or it's R. Premise 2 says, if P is true, then Q is true, and if R is true, then S is true. And therefore, the conclusion we draw is either Q or S. Now, notice what we've actually done here is if we just start by pulling apart the conjunction, these two different conditional statements put together by an and. If we just rip these apart and look at them individually, notice we could take the first conditional statement, if P then Q, and just place it off on its own as a major premise in either a modus ponens or a modus tollens. The second premise is going to appeal to the disjunctive claim, and it will find whatever term I can use to resolve the particular statement. So in this case, of course, R has nothing to do with this conditional statement, so I can just leave it alone and go use the P. So the second premise simply says P. So premise 1 says if P then Q. Premise 2, taken from this disjunctive claim, simply says P. And of course, notice Q follows at the end. That we can borrow from the disjunctive statement that is our conclusion. S doesn't really help us here, so we can just pull out, I have if P then Q. I want to find how I resolve both P and Q by way of these two disjuncts. And in the end, I'm left with basically just this statement. And of course, what do we get here? This is a valid modus ponens. That's all it is. If P then Q, P is true, therefore Q is true. And so on this side of our constructive dilemma, notice what we have with the if P then Q and all the terms that help us resolve it is just a modus ponens. And of course, we can do the same thing with the other side, right? We can tear out the if R then S and place it off on its own as its own premise, and then just start filling in the rest by appealing to the second premise, which is our disjunctive here, was given originally as a first premise. Notice R now is the only thing we have left to use, and so I can just put R there, and then the conclusion will give us S. And of course, notice what we have in this case is once again just a valid modus ponens, right? So if you think about what a constructive dilemma is, it's really just, in this case, two modus ponens, both of which in this instance are valid, smashed together by way of an or claim. And that's pretty much all there is to it. So to determine the validity of the argument, the basic rule is really simple. Tear it apart into its basic foundations, modus ponens or modus tollens, and make sure that it is valid all the way through the argument. If it's valid all the way through the argument, that is, both conditional statements resolve themselves into valid modus ponens or modus tollens, then it's a valid constructive dilemma. Now, if each conditional statement in the dilemma resolves itself using the rules of a valid modus ponens, then we know it's a valid constructive dilemma. So a valid constructive dilemma would look something like this. Now, it's worth mentioning that these can be far more complex and messy than this, but in the end, this would be the basic foundational structure of a classic valid constructive dilemma. Let's look at another example, in this case, an invalid form. So notice what we get here is in the first premise we have it's either Q or it's S. The second premise says if P then Q and if R then S. And then in our conclusion we get it's either P or it is R. So let's tear this apart into its basic building blocks, which is going to be either modus ponens or modus tollens. So let's tear out the particular conditional statements and place them in their own little argument. We have if P then Q, and we can write that down. Now notice the second premise, the only term that is of use to us here is Q, and so I have to use that because it's part of my premises, and so put Q there as the second premise in the modus ponens. And then of course P is in our conclusion. R doesn't help us at all, so we want to write down P, and what do we get by the time we're done? This half of the argument is invalid because it commits a fallacy of affirming the consequent. Remember, with a modus ponens, we always want to affirm moving from the antecedent to the consequent, not backwards. And frankly, if one of these two parts fails, you really don't need to go on to check the other side, because it's only valid if it's valid all the way through the argument, every step of the way. Each and every step is a valid piece of modus ponens or modus tollens. And if it fails even in one point, then it's not a valid argument. Now, if any conditional statement then in a dilemma resolves itself by breaking the rules of modus ponens, that is, it commits the fallacy of affirming the consequent, then it is an invalid constructive dilemma. Now notice it's still a constructive dilemma because it's using the rules of modus ponens, it just used them wrong. And that's how you can tell if it's a valid or invalid dilemma, is to just go test it by way of the rules of modus ponens or modus tollens. So what we get here is an invalid constructive dilemma, and you can see why from this side, and both sides would actually resolve themselves into invalid forms. But you can see why based simply on the rules of modus ponens. So what about a destructive dilemma? A destructive dilemma is pretty much the same thing, but it works by using the rules of modus tollens. So it wants to deny things. And this is the last of our syllogisms. This chart here is everything you need to know in terms of standard form syllogisms, as well as all the various fallacies that are committed. And really, there are only three you need to know: one for a disjunctive syllogism, one for a modus ponens, and one for a modus tollens. So let's take a look at an example of a valid destructive dilemma. So our first premise is what it's supposed to be, which is simply a disjunctive proposition. It is not Q or not S. The second premise is two conjoined conditional statements, if P then Q and if R then S. And then the conclusion, of course, is not P or not R. Once again, how we determine the validity of the argument and ultimately how we identify what kind of dilemma we're talking about is to simply tear out the individual conditional statements and then resolve them by looking at the premise and the conclusion and the appropriate terms in our disjunctions. So what we get here is if P then Q, we can set that up as the original premise of either modus ponens or tollens. And of course, notice when we have P and Q as our two terms in this original disjunctive statement, not Q or not S, Q is the only one that is useful to us. And so we have to take that as our example or as our second premise. We get not Q. And of course, the same thing is true here between P and R. Our conclusion has to be not P on this side. And what we end up with is a nice valid modus tollens. because of course a modus tollens takes our original conditional statement and it wants to deny the consequent in order to deny the antecedent. And of course we can do the same thing to the other side. We get if R then S as the basic building block or the premise for either a modus ponens or modus tollens. And then we can go to the only term that's left for us to use in this case. In this disjunctant, S is left to us, but it's negated, so we write that down. And then our conclusion, we have to use the R on this side of things. And so we get not R as our conclusion. And of course, this too is just a valid modus tollens. And this particular argument is essentially two valid modus tollens smashed together by way of a disjunction. Now, if each conditional statement in a dilemma resolves itself using the rules of a valid modus tollens, then we call this a valid destructive dilemma. Destructive because it's using the rules of modus tollens, whether valid or not, and it's valid because all the way through the argument, every single piece resolves itself into a valid modus tollens. So this is a valid destructive dilemma, or an example of one. And of course, things can get really complicated. And the basic rule we talked about earlier on in this video about affirming and denying applies here, just like it applies to modus ponens, modus tollens, and to pure hypothetical syllogisms. When I say affirming and denying, make sure that it is always relative to the original case. So let's look at an example of an invalid destructive dilemma and how we would want to deal with that. So in this case, we get not P or not R as our first premise. Second premise is our conjunction with if P then Q and if R then S, and then we conclude not Q or not S. If we start tearing this apart, we can just rip out the first conditional statement, which is if P then Q. And then, of course, we must turn to the not P side because not R isn't useful here. It doesn't always have to show up in this order, but what you want to do is go find the terms that's going to be most useful for you. And then, of course, in our conclusion, we have not Q, since not S has nothing to do with P or Q. And what do we get? Well, it turns out that this is an invalid form of a modus tollens. We get a fallacy of denying the antecedent because it begins by denying the antecedent in order to deny the consequent. And as we talked about with modus tollens, this simply doesn't work. And of course, if one side fails, you don't really need to keep going because there's nothing else to check. It has to be an invalid argument. For it to be valid, it must be valid all the way through. So if any conditional statement in the dilemma resolves itself by breaking the rules of modus tollens, that is, it commits the fallacy of denying an antecedent, then it is an invalid destructive dilemma. Now, it's still a destructive dilemma because it's using the rules of modus tollens. It's just, again, doing it poorly, and so it ends up being an invalid form. And so what we get in this case is a nice example of an invalid destructive dilemma, and it's invalid for the reasons we've already seen. Now, let's look at one last example of a dilemma, and you might just say, how do we deal with problematic cases, or sort of the weird oddities that will show up with dilemmas? Because dilemmas can be actually really weird and complicated. In the end, we're still just dealing with the same basic point, but let me show you what I mean by way of just one example, and they'll get worse as you start dealing with them. So take this example. It says, it is not P or it is P. So we get an exclusive disjunction in this case on the top. And then it says if P is true, then Q, and if R is true, then not P. And our conclusion then is Q or R. So let's start doing what we've been doing with all these other examples. We can begin by simply tearing apart the argument in terms of picking out the various and individual conditional statements. So we'll start with if P then Q, which is a nice basic conditional statement. And so what we want to do is see from this point forward how we can produce our mixed hypotheticals out of this, either modus ponens or modus tollens. Now, of course, what we know is that P has to be used here. And the question we have to ask is, do I want to affirm or deny it? Because I have both of these options. They're both quite useful for me at this point. And so I could either put in not P or I could put in P. And the basic rule you want to follow here is pretty simple. Do your best to make it a valid argument. So pick what you can in here that's going to work in your favor to try to make this first instance valid. And of course, what we want here is not the negation, because if I negate on that side, I'm going to get a fallacy of denying the antecedent. So I want to use the P term that is not negated. So again, when you find yourself facing this sort of dilemma where you have to pick between the options given you, do what you can to make it valid. Just get comfortable with the rules of what makes a modus tollens valid and what makes a modus ponens valid. And of course, again, notice with the modus tollens, when I'm denying, I always want to deny going backwards. I should try to deny the consequent and affirm the antecedent. So in this case, I want to take the term on the right-hand side. I want P because it's the only one that's going to help me try to make this a valid argument. And then, of course, the only option there is Q. Q and R don't really help in terms of both of them. I don't have this crisis where I have to figure out which one to use. The only one that can do anything of value to me at all in this particular instance would be Q. And notice what this does for us. I now have a valid modus ponens on this side of the argument. So far, so good. If it were literally impossible to construct a valid form out of this using anything in the second premise there, the not P or P, then it would be an invalid dilemma. But so far, we're on the right track in terms of building a particularly valid dilemma. And what's left to us then is to just see what happens with whatever's left over. So we can start by just tearing out this particular conditional statement. If R, then not P. Now notice I have to work with whatever is left over that wasn't used in the original modus ponens that I saw on the left-hand side there in blue. So in this case, I have to use the not P and throw it into the form that I'm trying to construct here, whether it's a modus ponens, modus tollens, and so on. So I get not P as a second premise. And of course, R is the only thing left to me. It actually fits the argument, so I want to throw it in there, and this is what I end up with. Now notice the second premise here, even though I'm dealing with a negation, is actually affirming the consequent, because the consequent says not P, and the second premise says, yes, you're right, I agree with you, not P is the case. And so what I have is affirming on the right-hand side, and then of course I affirm in the conclusion, which means I get a fallacy of affirming the consequent. So when you find yourself facing this kind of a struggle where you don't know exactly which term to pick, with the first instance, do everything you can to make it valid. And then in the second instance, just resolve and see what happens. If it's valid, then it's a valid argument. If it's invalid, then it's an invalid argument. And notice what we end up with here. This is still a constructive dilemma, but it's an invalid one because it's not using the rules of modus ponens validly all the way through the argument. So if either conditional statement in a dilemma resolves itself into an invalid form of a modus ponens or a modus tollens, then it would have to be an invalid dilemma. So in this particular instance, it's a nice example of an invalid and again constructive dilemma because it is using the rules of modus ponens even though it failed on the right-hand side. So that's all there is to this. These are the various rules you need to know. So we have disjunctive syllogisms, hypothetical syllogisms in its three different forms, a pure hypothetical, modus ponens, modus tollens, and then we have dilemmas, either constructive or destructive. You should know the basic defining features of these. You should know how to recognize what you're looking at so that you can identify these things and say, yes, that's a modus ponens, this is a destructive dilemma, this is a disjunctive syllogism, and so on. And then ultimately you need to be able to tell if it's valid or invalid by doing nothing more than simply looking at the form of the argument. And then of course the last step is, in some of these cases, you should also be able to name the fallacy that is committed. So I promise you all of this will be very useful. You will be tested on it in this particular test that's coming up pretty quickly here. and it will be instrumental in understanding everything else we do for the rest of the quarter in natural deduction.